Morning, everybody.
Good morning.
Okay, I guess we can get started. So the agenda for today's session is on the screen. Few more things about the TypeScript, like the integration of TypeScript with the popular JavaScript frameworks and libraries, precisely with respect to Angular and React, where more focus will be on React. Then setting up the TypeScript project with a framework or library like React, best practices for using TypeScript for the same reason, like while being used with frameworks and libraries. Then how to use the best practices for writing the clean and maintainable TypeScript code. Discussion on the common pitfalls with respect to TypeScript and how we avoid the same. And then tips and tricks for working more and more effectively with JavaScript, TypeScript. Okay, so let's start with the very first part, introduction to popular frameworks and libraries that use TypeScript. Okay, so as we know, the TypeScript is a statically typed, or in other words, we can say fully compiled superset of JavaScript language, which has gained quite significant popularity in the web development community. Many of the popular frameworks, libraries now have adopted the TypeScript language to enhance their developers' productivity and the maintainability of the code. Correct? We already discussed that in the previous session. Correct? So, what are those frameworks and libraries? One by one, we will be listing them down. First one is Angular. And why it is first one? Because Angular was the first framework or library that adopted TypeScript full-fledgedly. It was Angular, which was completely a JavaScript-based framework. In fact, it used to be known as Angular JS because of it being based on JavaScript. While releasing version 2, it adopted TypeScript outright. It said that my implementation itself basically has been done in TypeScript, and hence I recommend developers also to use TypeScript only while using the Angular framework. Precisely Angular 2 onwards, this was the case, right? So as Angular is governed by Google, the statement was by Google that Angular 2 onwards kindly make use of TypeScript outright, right? Now what Angular actually is? Angular itself is a pretty comprehensive front-end framework developed and maintained by Google, follows the MV star architecture, model view, and star means it could be anything. It could be model view controller, model view view model view presenter. There are different flavors of model view controller, right? Depending on the kind of application you are creating. So we call it as MV star. It doesn't say that the implementation needs to be always MVC based or MVP based or MVVM based. It all depends on your application's need. Correct? So MV star. Version 2, as I said, was completely built with TypeScript. Hence, there was an encouragement for the use of TypeScript for building the web applications using Angular. It was a complete push by Google to make the life of the developers much more easier. Angular itself provides a very powerful set of tools for building large-scale applications with features like two-way data binding, dependency injection, pretty robust component-based architecture, which makes the complete business-oriented applications, very complex business-oriented applications, line of business applications, more suitable to work with, right? You have too much data, too many decision-making situations, and that's where having a robust framework always helps. Yes or no? Angular actually became popular for that. Next one to follow was React. Though even today, React makers have never made statement that it is TypeScript way forward like Angular, but most of the developer community which works with React, which uses React for developing the front-end applications, feel that TypeScript is the better option. It's not a framework, it's a front-end library which was developed by Facebook initially for their own product, Facebook itself. Later on was released to the developer community, allowing the different developers across the world to use this library to build the client-side web applications easily. React library, if I talk about, itself is primarily written in JavaScript, unlike Angular. Angular was written in TypeScript, but React is written in JavaScript. But at the same time, as we know, TypeScript is the superset of JavaScript and follows all ECMAScript standards, latest ones. It is completely interoperable with JavaScript. And hence, React also supports TypeScript fully, for which it makes use of something called as TypeScript declaration files, which are officially made available by React makers. Script can seamlessly integrate into the React projects, providing the enhanced type checking and auto completion, what we have seen in the previous session for basic TypeScript code itself. All the benefits of TypeScript are available if you're making use of TypeScript as the coding language for React. Ultimately, after transpiling, you will have JavaScript only. So browser will be running the typical JavaScript based React code only. But as a developer, you will still be making use of JavaScript. Then there is another library called as Vue.js, derived from React only, I would say, because in many terms it is same as React. But then what are the shortcomings or shortfalls of React.js were there? It just overcomes them and provides more enhanced features. And hence becoming very, very popular for the front-end development. They have simplified Vue.js further to make it even easy to use. Like React.js, Vue.js is also primarily built using JavaScript, primarily associated with JavaScript, but still it has excellent support for TypeScript as well, which means the developers can write the Vue components using JavaScript, using TypeScript, and which allows the auto completion behavior to be used. Also allows the type checking at compile time, which means it helps in catching the errors early in the coding stage and later on improve the code maintainability for a long time. Then we have Node.js and Express.js. What Node.js is and Express.js is, we know that. Purely server-side environment that allows JavaScript to be used for creating the server-side code. Express.js is an extension to Node, which allows the RESTful APIs to be built pretty quickly and pretty easily. And this is where also we have the full support for TypeScript, which brings in all the benefits of TypeScript to Node and Express also. Next one is RxJS, which itself is a library for reactive programming that heavily uses one of the ECMAScript feature called as observables that allows you to change the UI based on the change in the data source pretty quickly with minimum code and by using more convention-based coding. Usually this RxJS is used as an extension along with Angular to make the Angular applications behave in a reactive manner. And hence, this RxJS can also be written, RxJS code can also be written using TypeScript, which by default provides strong typing, compile time, error checking, etc., along with the auto completion to RxJS also, right? And then has got full support for asynchronous operations as well. Then there is an extension for React as well. Not a React extension as such, it's an independent extension, but usually integrated with React most of the time. That's why I made the statement that it's a React extension. So we have something called as Redux, which is a state management library that is used primarily with React.js, but can equally be used with Vue.js, AngularJS, etc. Global state management, if you're looking to do, application level state management, if you're looking to do, that's where Redux can help. And TypeScript is fully integrated with that also, or fully compatible. so that you can define the strong types for its artifacts like actions, reducers, and the overall application state, right? There are some other libraries also, but in fact, this list is quite long. What I've done is I've put the most popularly used frameworks and libraries in JavaScript that support the use of TypeScript outrightly. Is it clear?
Yes.
With large scale enterprise applications, it's quite important to have strong typing, compile time checking, auto completion, support for async programming, and availability of different tool sets, right? Otherwise, your development time probably can get affected negatively. Yes or no? Yes or no?
Yes.
Okay, so now let's see how do I set up React application and how do I make sure that this React application is actually created using TypeScript. So for that, let's open the command prompt. Same command prompt that we have been using so far. And let's go to the path where all of our demos are present. So under my user folder, OneDrive, desktop is the location where I have a folder by the name Quinnox, which has got demos. All the types of demos are here. And now because I'm starting with the React.js project, I'll create another folder called as React.js and switch to it. I want a project to be created over here with the name demo1. So let's say I create another directory called as demo1 and switch to it. Then to create the React applications, there are different ways. I can set up an application with the help of npm. Package.json I can use then to have all the React dependencies downloaded as npm packages. The complete bootstrapping I can handle on my own, right? Different other package managers also I can use. And then there is a easy way where I make use of a tool that just sets up the initial bootstrapping for the complete React environment on its own. The test runners, the compilation, everything gets set up for me with one single command. But for that, I need to get that tool installed. That tool is something what we call as Create React App. The name of the tool itself is Create React App. So how do I install? In itself, it's a package on npm. So I say npm I or install -g for globally installing it so that on the entire machine I can use this tool anywhere. Then I say create dash react dash app. The name of the tool which I want to install is create react app. Written like this, create dash react dash app. Enter. Create React app gets automatically installed locally on your machine. Is it clear? I also want the
Sachin,
theming. Yeah,
so Sachin,
go ahead.
every time you create a new project of Reactor, this is the only way that we can do.
See, there are two things I will comment over here. One is this create React app you need to set up only once. on one machine. Next time onwards, you just need to make use of the command. But then this is not the only way. As I said, you can just set up the React application from scratch also by making use of the different package managers like uh, uh, Bower, right? In addition to NPM, the other tooling, whatever is required, the compiler setup, whatever is required, all configuration you have to make manually. You have to create those config files. You have to install those packages one by one manually. Now, there are around 7-8 packages and tools that you need to install, plus plenty of configuration for them. Every time when you create a new React application, if you keep on doing this manually, it will affect your productivity, isn't it? That's why the same task has been automated for you. Just like how I can create a web API application on .NET 5 or .NET 6 using command line and Visual Studio Code. Compared the same with how I create the web API application in Visual Studio. What is the difference? With Visual Studio, I get a proper template, isn't it?
Yeah.
I don't need to put any configuration which is required mandatorily just to make that web API application work. It comes by default. Yes or no?
Right.
If I use command line, many of those configuration items I have to code manually. Yes or no?
Yes.
There is no
Continue.
initial scaffolding which is done on its own. Sample
Right.
API probably also doesn't get available. Just if I want to try out few things. I don't want to spend much time on just setting up the project. I just want to kickstart my project to showcase something quickly. So I want that initial scaffolding to be automated.
Yeah.
And it is standard based only. I mean, even if you're creating the application from scratch, you will be ultimately ending up with the same configuration which this tool Create React App will give you. So why not use this? This saves time, right?
Right.
So though it's not mandatory, but it's a better option. And once you are used to it, you know what environment is required, what configuration is required. Probably then you can move away from Create React App and start creating the applications from scratch. Make sense?
Yes.
Quickly get the configuration done. You might maintain some master copies of the configuration as a template. And whenever you create a new application, you just copy and paste that same configuration with minor changes like names and all, right?
Okay. Yes. Yes.
But that's a later thing. Once we are aware of what is React, right?
Yeah. So when I hit this command, I'm getting invalid command, unknown command for create React app.
Can you share your screen?
Okay. I've installed TypeScript also, but globally I installed.
NPM, remove hyphen before I. It should be NPM I. I is for install. Enter. Looks like working, right?
Yes. Yeah. Sorry. Yeah. Thank you.
I hope this is clear now. So Create React App is not the only way, but yes, one of the quick way to get started, right? Without wasting too much time on understanding the initial bootstrapping configuration, right?
Yeah.
Next, once this is done, I want to make sure that my application uses a theming framework into it, some CSS based theming framework into it, so that I get the nice looking UI created. So optionally, I can specify that it should be Bootstrap or whatever other theming framework I want to go ahead with. Let's say I go with Bootstrap. So I say npm I bootstrap -- save. Save will make sure that the entry of this bootstrap package is made into dependencies section, not dev dependencies. Okay. And now I want the application to be created as well. So here I say create -react -app app name. This app name could be anything what you want. Let's say I want to call it as demo1, as I've created it into folder demo1. Make sure that whenever you create a React application, naming should always make use of all small letters. If you use a capitalized letter, it won't be understood. Okay. If I press enter here, it will create the React application with JavaScript as the coding language. What is our target? What we are looking to have? Is it JavaScript or is it TypeScript?
TypeScript.
TypeScript. So additionally, I put -- template space TypeScript, which forces that application to be created as a TypeScript based React application. Press enter, and your first application should get created with the given name. This is what I was talking about, installing different packages like React, React DOM, React scripts. Manually, you have to install all these packages, though it is a basic necessity. The React applications will always require some packages every time.
Saket, I am getting one error.
Unknown command it is saying. Sorry, it's not recognized. Create React app is not recognized.
As an internal
Try
or
using it along with npx space create React app.
Okay.
Like what we did for some of the commands in the last session.
Right.
So that's because of some path related configuration issues.
Do I need to install this TypeScript locally as well? I mean, I have installed globally. Not necessarily. Right?
Create React app or TypeScript?
No, TypeScript.
It's not needed. If it is installed globally, that's fine.
Yeah. I think it is working in NPX.
NPX is
Yeah, it
okay.
should work with NPX. If it is showing unknown command with NPX, the problem should get solved.
Yeah. It's working.
The same command, just prefix that with npx space.
Yes. Yes. So when we create this app, this in node modules is again, it will be created in the local folder, right?
Correct. So here, if I issue the dir command, it should show me the same. Okay, it created another directory called as demo1. No issues. I'll just go inside this. And here, if we see, we do have node modules. Yeah. And all the config files also are there, like package.json is already there. tsconfig.json is already there.
In my case, actually, it doesn't create a new folder. It is creating all the packages within the same, actually.
That's fine. That's fine. I actually expected that only. Maybe because the folder name has got capital letter in its name initially, it created a subfolder for me. Okay. So that's fine. If it has created a subfolder, get inside that by using the cd command. Otherwise, we are good to go. We need these folders and these files. This is more important. Now see here, once the command completes, what it shows. Some suggestions, right? It says if you want to start the development server and immediately you want to see the output of what your application is initially, npm start is the command. Npm run build. This is only for bundling the application into the set of static files for getting deployed into the production environment. Right? If you want to host your application on some web server, you might need this. npm test will start the test runner that has been configured with your application. Jest, Jasmine, Karma, whichever one you have configured. npm run eject removes this tool and copies the build dependencies, config files, scripts into the main application directory. And this is an undoable action. Removes this tool means create React app is removed. And then there is a suggestion. You get inside the project folder and then say npm start. Right, so I am already inside the folder. I just need to say npm start. Remember, you have to issue this command npm start at the same path where your package.json file is present. So make sure you issue the dir command and verify that you have the same path right now activated where package.json is present. npm start, if doesn't work for any one of you, you can also go for npx start. Most likely npm start should not have any problem. Press enter and it automatically starts the development server, automatically launches the browser also with the sample content being displayed into it. And I can see it has started a self-hosted web server on the local host on the port number 3000. Yes?
Saket, I am getting error.
What is the error?
Missing script start.
Okay, can you share your screen?
Yes.
I think we have package JSON inside the project folder as well as this local folder.
Do you see my screen?
Yes.
Maybe this.
In my case as well, that TS config is not present. If you check your directory.
You might have missed that hyphen template TypeScript.
I am given this.
Given for me also same issue. Second, maybe this demo one folder is there, right? We got two packages and
so
files.
get inside the subfolder. Get inside the subfolder demo.
So here we have a package JSON.
Yeah.
The project name we have again React.js. Go to React.js folder. You have another packages. React.js folder. Oh, it's not there for me. It is there. Okay. Here. See.
Okay, run this command again. Create React app. Just go to command line.
Do you see my screen?
Yes. Just run the command. You might need npx to be prefixed.
Actually.
Yeah. Enter.
Actually.
Yeah, now see it is creating the subfolder demo one. It will create the subfolder for sure.
So the previous data, do you want me to delete that?
You can delete, no issues. You mean the package.json and node modules which is created outside, right? You can delete that, no problem. Now issue the command cd demo one. cd demo one. It says aborting installation and it also says deleting generated file. It has deleted the folder as well. There seems to be some
system cannot find
error.
Yeah, it is not.
Do one thing. Uh, yeah, in File Explorer itself, go to the React.js folder.
Okay.
Before that, just go to command line and press. Type cd dot command and press enter. In command line.
So here,
Yes, cd dot. Okay, now go back to File Explorer.
okay.
Delete this demo1 folder. Yes. And back on the command line. Try running that npx create react app once again.
This is the one, right?
Yes.
In my case, actually, it is not create. It is doesn't create any folder demo one.
Yeah.
After completion of that, actually.
Yeah, we'll check that also.
Okay.
This now seems to be going fine. Almost done. Okay,
It's
now
done.
just issue the dir command. There should be a folder demo1. Say cd demo1 dir. Now issue npm space start. The dev server should get started and the browser should open up.
But here is also ts config is not there, right?
Ideally, it should be. Let's
Actually,
see.
in my case, it is showing after executing that npx command create react app. It is a failing actually. Aborting installation is I'm getting.
So it might be the same problem like what we saw. So if you have the demo1 folder already created, delete that and
Yeah,
just
same. Yeah, same thing I have done actually.
Okay, we'll check. We'll check.
I,
Let the page be loaded, and
So,
then you can stop sharing.
yeah.
Okay, there is some problem here. Probably there is some problem with the TypeScript itself. Okay, did you install TypeScript successfully the other day?
Yes.
Then it should have been here. Even
Not resolve.
yeah, so because it is not able to compile TypeScript, basically, the error is just because of that only. Can you just type TSC?
Shall I stop this?
Okay, stop. Wait. Just press Control C there. Press Y, enter. Now type npx start. Npx start. Okay. Cannot resolve /app, right? That's the error. Just hold on.
I think that day we installed TypeScript for that particular folder.
You didn't install it globally, is it?
Yeah, actually, TypeScript. I think we, to this folder only we installed.
Do one thing. Just go back to the command line.
Yeah.
Type cd dot dot. Go to File Explorer and delete demo1 folder again. First install TypeScript globally. npm i-g TypeScript. I-g TypeScript.
Enter.
Yes. Done, right?
Yes.
Just type TSC. Enter. Okay. No worries. npx TSC. npx TSC. This seems to be working. Just press Control C. Okay, it's done. Now issue that command, create React app. We deleted demo1, right?
It's still deleting.
Okay, it's going on. Let's wait for a while.
So what we have to do to get TS file?
Wait.
Okay.
TypeScript should be the globally installed one, first of all. Just make sure if you have it. Otherwise, we'll check it. Okay.
Now shall I issue this command?
Yes.
Like in Angular, we will create the same npm create new. This it is the same
Right,
with.
right. Correct, correct. So we have a tool which basically runs those individual commands for us. Creating the React app, setting up package.json, setting up the compiler, setting up the other tools, right?
Yes.
I'm able
Webpack
to
and Babel, everything gets configured automatically with this command.
I'm able to run the application, but this
Yeah.
t.ts file is not great.
Getting error, or is it just working fine?
No, application is working fine. It's loaded.
Okay. I'll just have a look at that also.
Okay.
We just need to verify whether the application got created as a TypeScript application or JavaScript application. So just a moment.
In my case as well, TS config is not there, and I just
Hmm.
start the npm start, and it is showing the same error which Verma was
Uh-huh.
facing actually, or in browser.
Mhm. Well, let's see if we get the solution here.
Mhm.
Otherwise, we'll take it up one by one. Okay.
So I install that bootstrap also.
For now, you can ignore that also. That was just to let you know. Okay. Right now, we'll not be using it immediately. So that's fine. If you have not done that, that's fine.
So now shall I issue this npm start?
Yes, yes. You have to go to that directory first of all, demo one.
Okay.
CD demo one, npm start. The application is getting created. There is no problem with that. Same error, right?
Yeah.
Okay, just go to command line. Press Control C. Type code space dot. Enter to open VS Code. Okay. Press the authors. Now see, there is no TS config, right?
Yes.
Create a file manually by the name tsconfig.json. tsconfig.json. Enter. Open the file and look at the chat box. I have given some configuration. Just copy and paste the same here. That's the default configuration. I just copied it from my app. Save.
Okay.
Save it. Go back to
Yes.
command line. Now type npm start. Ideally, CRA should have created this file automatically for you.
Yeah, for me it is created actually. I don't know. I have followed the same steps.
Mm-hmm.
Saying some other errors.
Okay.
Module not found.
Web Vitals, it's not able to find, could not find a declaration file for module React implicitly has an type, multiple modules. Okay, can you just go back to VS Code again? Open package.json file once.
Okay.
Package.json. React DOM, React scripts. Okay. Just hold on. Select all the 4 statements under dependencies. I mean, line number 6 to line number 9 and delete them.
Shall I delete?
Yeah, delete. Now go back to your chat window. I've given the configuration which ideally should have been placed here in the chat box. Copy that.
Line
Last
number
one,
which?
last one. Line number 6 to line number 9. If it was same as bar numbers.
Yeah, dependencies, right?
Yeah, clear the dependency content. Okay.
Okay.
So I copied
Now
and
paste. Yeah, paste that under dependencies only. Okay. Just remove the blank lines. Save. Go back to command line. Press Control C. Y. npm start. working, right?
It started.
Okay. The browser is not yet launched, is it?
Yeah.
Most likely this should work because your issue was only about the dependencies not being created. Got it?
Yes.
TS config should automatically come in with CRA. So there is a misbehavior of CRA for both the things. TS config it was not able to place, and dependencies it was not able to put in correctly. Your application is using some dependencies and those modules were unavailable. So error. That's why when we put dependencies in place and we manually added tsconfig.json, ideally it should start working. Okay, still we do have a problem. Okay, go back and say Control C. Go to command line, press Control C.
Okay.
And issue the command npm I. npm space I. Enter. So any missing modules, it should automatically install. Enter.
So now start the npm start.
Yes. Sometimes this happens because of the low internet bandwidth also. As far as manually you are able to get it done, that should be fine.
Find module logo.s.
Yeah, some file is missing. So see, this must be there in your app.ts. Go to VS Code. We'll just remove this dependency. Go to VS Code.
Okay.
Simply what's happening, it is looking for a file which doesn't exist, right?
Yeah.
There is logo.svg. Try to select that file,
This one.
logo.svg.
Yeah.
Okay, so there is a file. It should be able to be loaded. Go to app.tsx.
It says
/logo.svg. Just comment that line, import statement for now. We'll see why it is not able to load. Ideally, it should, because file exists. Save.
now here we are getting line number 9.
Comment that also. Line number 9. Complete line number 9 can be commented. That's because now logo is not available, right? We are not importing it. Save. Go back to command line. npm start. working, right?
Yeah, it launched the browser, not it.
Yeah. That's fine. React logo is not coming. That's fine because we commented that logo thing, right? You can replace that with any other image if it is not able to load that file. Clear?
Okay.
Okay, so some manual intervention required just because probably in this create React app command is not able to download some of the things the way it should be. Got my point?
Yes. So here, so maybe I will stop. You can share yours.
Yeah. Yeah.
We will see.
Saket, I have an
Yeah,
issue
Bhushan.
actually.
Yeah.
Yeah, I'm just sharing my screen.
Sure.
So, are you able to see my screen?
Yes.
Yeah, I have this actually same error after doing all the steps which we
Cannot
did right now.
resolve this, right?
Yeah,
Okay. Can you go to VS Code? I mean,
okay.
launch VS Code.
Yeah, I have launched.
Package.json you have modified. You have tsconfig.json also. Can I see tsconfig?
Yes.
Okay, just format it.
Okay.
Make it readable.
Okay. Is there any shortcut for this? Do you know?
I
Right
think
click
that
and you should get.
TS file is inside SRC. It should come.
Yeah, it should be
Oh,
at the root folder. Just drag and drop that file
okay,
outside.
sure.
No, drag and drop it over
Demo.
package.json.
Yeah, demo
Demo
already.
one, yeah.
Yeah, demo.
Just a minute. No, still, I think I'm just dropping here.
Pull it
Actually.
down. Pull it down.
Yeah, can I just go through this one as well?
Yeah, no problem. No problem. Cut it and paste it at the root.
Yeah.
Go to VS Code.
Okay, it's right
It
now
should
it's
be okay.
outside.
Yes. Yes. Close that tab which is showing error because the file
Just
is moving. Right?
you right click and format. There is an option.
Oh,
Right click and format.
Yeah,
okay.
format.
Yeah.
Save
Yeah, that.
this
Yeah, saved.
and go back to command line. Control C, Y, npm start.
Oh, yeah, again this one. So I will comment that one. Right.
Yes, the 2 lines of code, you know that. Right? For some
Uh,
reason, it is not able to pick up that file
okay, sure.
from the path.
It's
Yeah.
it's in the
Yeah, that's fine. That's why.
okay, yeah.
Yeah, app.ts.
TSX, right? This one
App.tsx. Yeah.
and this one, right?
So line number 2 and yeah, imgsrc.
Yeah.
Could
Okay.
be
I will.
because of some permissions also on the files that it's not able to read. Otherwise, there is no problem as such. Okay.
Okay. Yeah, sure. I'm just stopping. Yeah.
Yeah. Okay, so I hope everyone understood how to set it up and how to overcome some issues manually if CRA is having some trouble downloading some of the artifacts. Yes?
Yes.
Okay, so time for the break. After the break, we'll continue with the next part where we'll be looking at the best practices for using TypeScript with frameworks and libraries. Okay?
Yeah,
Thank
sure.
you.
Thank you.
Yeah, so we'll be resuming at 11:10. Okay?
Okay.
Okay, guys, I'm back. Shall we proceed?
Yes, Sagar.
Okay. So the next section is the best practices to be followed for using the TypeScript with frameworks and libraries. Right? The advantage we already know. Basically, the advantage is the same as what you get by replacing JavaScript with TypeScript as a developer. So using TypeScript within some library, within some framework gives the same advantages to you again, right? But there are some best practices which must be adhered to so that you can ensure a smooth development process, get more maintainable code, and you can also see the reduced potential for errors. Okay. So the first practice I would say is to have type definitions and declarations. Okay. So what that means, you have to make sure that you have up-to-date type definitions for the libraries and the frameworks that you are using. Most of the libraries like React, Angular, etc., provide the official TypeScript declarations. So as we saw, a couple of members over here were having some issues related to dependencies. Web Vitals and a couple of other modules were not being detected. And there was a compiler error as well because of that. So that was just because that some of the features within that sample application were being used, which depended on some type definitions, and those type definition modules or the modules containing those type definitions were not available. So when we added the dependency section, we updated that. And when we saw the use of npm install command, we actually made those modules available. The type declarations and type definitions were made available, right? Usually that comes from a package called as add types, right? If you go to VS Code and see the package config package.json file, in that under dependencies, you will have one entry for add types. So that's where the type declarations and definitions are picked from. Right. So once you have the type definitions in place, type checking becomes much more faster, much more easier. Right. You can just match that. OK, this is the type I'm looking for. So that's the use of type definitions and declarations. So even if it is your custom type, you should actually create those type definition and declaration files and make available as a package along with your actual implementation. Understood? Then make use of strict TypeScript configuration. Strict configuration means what? The option strict must be set to true. Let me launch that VS Code window again. I'll show you a few things. So I go for launching command prompt. I go to the path. Okay. So here, if you see package.json, add types. This is the package I was talking about. Types for React, types for Node, types for React DOM. These are actually loading all of your type definitions. These are for the libraries for testing frameworks, right? And then the framework itself, the React DOM, etc. Now, the other thing I was talking about using the strict configuration, strict TypeScript configuration comes from here. Mainly, this is the configuration which we are talking about. Option strict set to true means that the type checking will be quite strict. There will be no loophole left. It enforces the type safety and allows you to catch the common programming errors related to the type mismatches easily. Clear? Allow JS true means the JavaScript is also allowed along with TypeScript. ECMAScript module interop true. So module interoperability is allowed. One module from another module can be used. Right, then no fall through cases and switch set to true. That means by default, if the switch statement contains at least a single statement into it, the fall through will not be allowed. If it is empty statement, empty case only, then only the fall through will be allowed, just like .NET. So that makes your code much more clearer, right? This is another important option, force consistent casing in file names. We discussed this the other day. Right. Next, use explicit types. Always explicitly annotate the variable types, or in simple terms, I will say, always give the data types for any variable that you create with the help of var, let, or even if you're defining a constant. Just like in the TypeScript sample code, we did that, right? Don't let the TypeScript always infer them automatically. Type inference should be used as less number of times as possible. Right? Yeah. So if you're creating an instance of the person class, in that case, you can actually say where P is equals to new person. Type inference is okay over here because on the right hand side, anyways, you are giving the type. Okay. But if it is where P only, then I should explicitly say what type of variable it is. So var could be var or const or let, depending on your need. I hope everyone understands this. Yes?
Yes.
Next is no use of implicit any type. You know, this can actually result in bugs. So we also discussed earlier that we have to avoid using any type as far as it is possible. We should use any if and only if there is no other choice, especially while interoperating with JavaScript. Because the TypeScript's main strength lies in its type system only. We are using TypeScript for type safety. And if we are using any data type, actually we are breaking the entire purpose of TypeScript. Yes or no? These best practices are generally applicable for any application that you create using TypeScript. Now, React specific best practices are also there. Which will be always in addition to what we have discussed on the top. Okay. React allows you to create components in two ways. One way is by using the class components. One way is using the functional components. Functional components use functions. And now, React 16 onwards, the makers of React, Facebook and Meta, basically have said, use functional components wherever the components are needed. So basically, what it means is prefer functional components. In future, probably the class components may not be supported at all, though they are being supported as of now for backward compatibility. So it's better to go with the new requirements. Prefer the functional components. And to add some additional functionality, some extensibility if you're looking for, make use of a React feature called as hooks. Which allow you to change the behavior of a functional component. Because the functional components are easier to create, easier to type, and typically have less amount of code. So they are generally more concise. Understood? Yes.
Yes.
Next is use the TypeScript's functional components. Type. This can be used to actually create the functional component in React, which is assisted by the TypeScript itself. Component that inherits from React.fc allows you to create the object pretty easily, right? It's a generic type in itself, so it can take in the type parameter also. So useful in some complicated scenarios where you're playing with lots of data. Then comes the type props. Always try to define and use the prop types explicitly. Props are basically the data members. So the best practice is that try to be as definitive as possible. Give the definite types. Okay. And for this, again, you can take help from the FC type also of TypeScript. Okay. Or you can make use of your own interfaces as well to define the types. Next is state management. While working with the state management libraries, like one we discussed earlier, sometime back, Redux, or any other library, there is one more popular one, just like Redux. We have something called as Mobex. Ensure that your actions and reducers have well-defined TypeScript types. Actions are like kind of replacement of hooks, which can add additional functionality to handle the state data. Clear? Clear?
Yes.
Let's talk about some of the Angular best practices, which will be over and above the general best practices for Angular. Use Angular CLI with the TypeScript support all the time. Right? So you have the ng command, ng new, and then app name you give there. Give the dash script strict flag all the times to make the TypeScript strict configuration all the time for your application, which also places the need for the next best practice, use the strict mode. Which you can do in tsconfig.json. The configuration for which is strict true. We have seen that. tsconfig.json will not change from application to application just because the framework or the library you are using is changing. tsconfig is TypeScript config. It has nothing to do with Angular or React or Vue.js. Understand?
Yes.
Use interfaces all the time for models. We discussed one of the features, right? Interfaces can be used for representing your data structures also, which can be easily extended as well. So that's what the recommendation says. Use the interfaces for defining the models so that your data models remain consistent throughout the application. Understand? Next is use dependency injection. Always don't hard code any dependencies anywhere. Okay. Okay.
Saket, in React, we don't have this dependency injection.
We do have. But React doesn't force us dependency injection all the time. And the way how we do dependency injection in React is such simple that you don't even realize that you are using the dependency injection. Component to component, we pass parameters, right? So that's where dependency injection automatically happens. There is no separate system for dependency injection where you can register your services and discover them when required. Angular does have a proper structure for that. Being a framework, Angular has an upper edge on it. Understood? So that is the reason why I didn't put that point for React, but I've put it for Angular. Yeah?
Okay.
Now let's have a review of the best practices for writing the clean and more maintainable TypeScript code. Because writing the clean and maintainable code is very, very crucial for the long-term success of any project. Simply, if your code is clean, it's easier to read, it's easier to understand, because you might have written that code, but you may not always keep on working on the same code all your life. Someone else also will be taking over that. So your code should not be understandable only to you, but for your team and the upcoming team members also. Yes. So if it is readable, if it is easily understandable, by default, it will be less error prone. and will simplify the collaboration among the team members. Yes or no?
Yes.
That's quite crucial. Now, if I talk about what should I be taking care of while targeting the clean and maintainable code precisely in TypeScript, it all starts with having a consistent coding style. The team level adoption should be there for a specific coding style so that whoever codes for that project follows the same coding style only. It might be about the naming conventions. It might be about the uh, casing that you are using for various objects and variables and other items, casing for function names, components, etc. Right? So there has to be some consistency. If it is jumbled up, readability and understanding will be at stake. So before you write your first line of code for any project, there has to be a team meeting within which it is discussed what kind of coding style the team is going to adopt. Adopt it as a team. It should be a widely accepted style guide that you should create. You might create your own style guide for that project or for the organization, or you might adopt some style guides which are openly available on the internet also. If you are not able to decide on a specific style guide or specific coding style, right? Understood? Simple requirement it is, isn't it?
Yes.
Then, while naming the variables and functions, use the descriptive naming. Your function and variable name should be descriptive. That doesn't mean they should be very long, but they should convey what they are holding or what service they provide. Correct? Again, a pretty regular thing. Descriptive, variable, and function names. Next, we're working with TypeScript. So ultimately, focus on the type annotations. Also is important. Explicitly use the type annotations, which helps you catch the type-related errors at compile time. Another one from our previous discussion comes up here. Use the any type as less as possible. Other way around, you can also say avoid any as far as possible. Right? Reason we already know. Any actually weakens the TypeScript's type checking and beats the purpose of TypeScript. Next is use type inference wherever available. But again, you have to be very clear while using type inference. One of the side, left-hand side or right-hand side, usually right-hand side, should be clearly stating what type is going to be used. Then on the left-hand side, you may avoid the type annotation explicitly. Just like we saw that example where P colon person equals to new person can be written as where P equals to new person, where type inference automatically gets picked up, right? Because on right-hand side, it's already clear. what type I am going to have for P. Yes?
Yes. Then what is annotation means it's a validations type
Annotation
annotation.
here is not validation. Annotation means the data type presence. So if I say var A colon int, sorry, number in this case, I'm clearly saying A will be a number. So this number is the type annotation. It's not a validation annotation like .NET. It's a data type annotation. Clear?
Okay, okay.
Okay. Then define clear and concise TypeScript interfaces or type aliases. For the complex data structures like objects, arrays, or function signatures. Some sort of forward declarations if you want to use that, okay, I expect this type of data or this type of functionality from this object. That's where the typical interfaces from object oriented features will come in, right? As a contract between the user and the provider. Yes. Next is use function, explicit function signatures. That includes the parameter types, return types of the functions, etc., which ultimately makes it easier to understand the, uh, how the function should be used, what input they take and what output they give back. So clear definition should be there. Clear? Avoid magic values. Like numbers or strings with some special meanings. Rather use the constants or enums so that you can give them the descriptive names. Okay, instead of hard coding them. Clear? Use modularization. What that mean? Organize your code into smaller, more modular files and directories so that each file can have a single responsibility, making it easier to maintain and test. Right? Typical advantage of modularity is what we expect. So that's applicable for any kind of code. And so is here. Use comments and documentations extensively. I need not talk much about this. This is a standard practice. And the reason why we do this is because, as I said sometime back, we are not the ones who will be working on that code all the lifetime. There will be other team members also. So even if our code is highly readable, but adding the comments to that code makes it further easily understandable and easily readable. Yes.
Yes.
Next is error handling. Your code should be written in a way that it actually implements a robust error handling using or exception handling blocks like try catch we discussed in the last session that allow you to handle and propagate the errors consistently throughout the application. Use the custom error classes or TypeScript enums for better error management, right? If you want very specific error messages to be conveyed and specific error handling to be done for your business case, then this is going to be important. Yes or no?
Yes.
Code review practice should be followed here as well. You know what is the advantage of it. With Git, we have already discussed about this. Yes?
Yeah.
To increase the overall quality of your code, we go for this. Next is linting and formatting. For which you can make use of some TypeScript tools, linter tools like TSLint or ESLint that allows you to make use of some TypeScript rules to enforce the coding standards and use a code formatter like Prettier to maintain the code consistency. Again, here you can take help from your code editor also. Just like sometime back in Visual Studio, we saw the format tool that arranged my code, which might be getting put on a single line into more readable multi-line format. We use that a couple of times, right?
Yes.
Do extensive testing to ensure the quality of your code, which includes unit test, integration test, so that you can ensure that any change that you are making to your code doesn't introduce regression at all, anytime. Yes, make use of version control. You know why it is important, so that you can track the changes to your code base. Commit as frequently as possible with meaningful commit messages. We already went through that dedicated session for the same. Use refactoring. So start with some hard-coded stuff, review it, and then to make it more dynamic, introduce changes. Make sure you are running the test cases immediately, right? This way you will be able to eliminate the duplication of your code. You can improve the readability and adhere to the evolving best practices easily, right? Use CI/CD so that your code compilation, before that linting, then compilation, then testing, then deployment, everything can be automated, which avoids the manual errors or human errors, right? Then dependency management. Keep all of your dependencies up to date. Review them, audit them regularly for any kind of vulnerability, logical vulnerability or security vulnerability, whatever. And for this, make use of the package managers like NPM or the other tools like NPM, other package managers like NPM. So you have Yarn also, right? Then keep regularly educating and training your team members. As a part of that practice, only this training is happening, right? Not everyone here is just a beginner, right? As a continuous learning and knowledge sharing is essential for the team's growth, organization's growth. Ultimately, it helps in maintaining the code quality in longer run, apart from learning the new technological advancements, right? Yes.
Yes.
Next is performance considerations. So you have to be mindful of performance when writing the code. Always use the appropriate data structures, algorithms, etc. Profile your code to identify and optimize any kind of bottleneck which might be getting encountered or which might get encountered in future. You have to do some anticipation also, right? You have to be future ready, right? So if you cope up with all these requirements, you can easily create the clean and maintainable TypeScript code, which will be easier to work with, easier to understand, easier to extend over time, reducing the technical depth and improving the overall quality of your application in longer run, right? Okay,
Yes.
let's talk now about the common pitfalls which might be encountered and how do we avoid them. So if we are aware of the upcoming issues, we will be in a better situation to cope up with them. Yes or no? Like while driving on the road, if you are driving on daily basis, probably you are aware of each and every uh, pothole also or speed breakers. So even if there is a blind spot created because of heavy traffic, you will still subconsciously avoid that speed breaker or the pothole easily because your subconscious mind always is active, telling you that there is a pothole, there is a speed breaker ahead. Yes or no?
Yes.
That becomes automatic day by day once you start driving on that road on daily basis. Maybe initially 1 or 2 times you may not be able to avoid it completely, but as you keep on driving on the road on regular basis, avoiding it comes naturally. So even if you're not watching the road carefully, by default, your instincts will make sure that you don't get into the pothole or the speed breaker badly. Your speed automatically will slow down. Yes or no?
Yes.
Now, this is the same practice. Can we bring that in the coding as well? So that's what this section is about. Knowing the common pitfalls If we know them, we can avoid them easily. Correct? So the first one is misuse of any type. What's the pitfall? We know using the any type more than required number of times at more than required number of places can weaken the type system of the TypeScript. Means type checking, which will hinder the code, which will hinder the code maintainability in long run, right? It doesn't mean that you should not use any. You can use any, but use it ideally only when you are interfacing or interoperating with some external JavaScript code. Provide explicit type annotations for variables and functions every time. Use any if and only if there is no other way. Got my point?
Yes.
Next point is neglecting type in inference. Failing to let the TypeScript infer types can lead to redundant and verbose means jumbled up type annotations. Wherever available, you are already aware of that there will be a type mapped. Make use of the type inference as far as possible, especially when it comes to the function return types or constant types, because you know that, okay, the value will be of specific type only. In such cases, the explicit annotation should be used if and only if necessary. Okay. Next point is avoiding non-nullable types. What's the pitfall for this? Using null and undefined heavily or excessively without the proper type handling can ultimately lead to unexpected runtime errors. You know, the null related errors. Many a times they are very difficult to identify and fix. So don't use them heavily. Rather, go for wise usage. Do some kind of validations for null and undefined checking, for which you can actually enable the strict null checks option into your tsconfig.json. Here you can specify strict null checks to true. Something like this. Okay. So as far as possible, first of all, use the non-nullable types like number, string. Instead of saying string, pipe null, pipe undefined, or number, pipe undefined, or NaN. Got my point? Yes.
Yes.
Next point is type assertions or typecasting is the other term for this. If you are overusing the type assertions or typecasting with the help of the as operator or any other way, any other syntax, can ultimately lead to type related runtime errors if your assertion is not correct. So in such cases, try to make use of or try to take advantage of type inference or well-defined interfaces or types instead of the typecasting or type assertions. Use type assertions or typecasting if and only if you have confidence in the fact that you are converting a type to another type and it's possible. It's compatible. It's containing compatible data. Otherwise, don't use it. Too much typecasting puts lots of load, lots of pressure on your compute resources also. I mean, processor precisely. Is it clear? Which ultimately hinders the performance. Next is mutable objects and immutable. Mutating means changing objects can directly lead to unexpected side effects and make the code pretty hard to understand and handle. For avoiding this, you should put more focus on immutable objects, for which you can use the libraries like immutable.js, or TypeScript provides a read-only access modifier to ensure the objects are not modified accidentally or by mistake. Understand? Yes.
Yes.
Next point is ignoring type compatibility. TypeScript uses a structural type system. Sometimes it can lead to unexpected type compatibility issues. So always be aware of TypeScript's type compatibility rules. Check if types are compatible, especially when dealing with generics, function parameters, return types of the functions, etc. Yeah, understood?
Yes.
Next point is neglecting enums and union types. Using the plain strings or numbers instead of enums or union types can lead to inconsistent and error-prone code. To avoid it, define enums or union types so that you can represent sets of related values easily, which ultimately helps you improve the code readability and help you catch the errors at compile time. Understood? Yes? Yes? Next point is unnecessary type complexity. Creating over complex type hierarchies, generics, can actually make your code base more harder to understand. Instead, strive for simplicity in your type definitions. Avoid unnecessary use of generics or type constraints unless they are actually genuinely adding the value. Okay, clear? Anyhow, overuse of everything is bad, right? Use all the features wisely. Next is incomplete type definitions. If you are relying on incomplete or outdated type definitions, it can lead to multiple type mismatches and runtime errors at the end. Hence, ensure your project has always up to date and accurate type definitions for libraries and dependencies, for which you can take help from that add types package for most of the popular libraries when available. So whether it is React or Angular, the add types package is going to be very useful to provide up to date type definitions. Next point is ignoring linting and static analysis. The moment you start ignoring the static analysis and linting procedures or linting tools, you will end up with having lots of inconsistencies and potential future issues into your code. Make use of the tools like TSLint, ESLint, TypeScript rules, etc., so that you can enforce the coding standards and catch the potential problems in early stage of the development. Got it? Yes.
Yes.
Then there is one very important feature of JavaScript, especially when it comes to the asynchronous operations, including the AJAX calls. The feature is promises. So this point is related to that, failing to handle promises. and ultimately async code. So can someone tell me what is promise in JavaScript? Promise says that if I have put the request for some action, I need the response at any cost. The response can be positive one, means successful execution. The response can be negative one, means failed execution, but I need a response at all costs. Promise doesn't mean that always successful execution is guaranteed. Usually that's what comes to mind. I'm not talking about that. JavaScript promises are about giving you the response, regardless of what happens. I give you an example here. You go to an ATM center, you try to withdraw some 10,000 rupees. Your machine doesn't show any response. In any case, whether the money is dispensed or not, there is no response on the screen. There is no sound either. Do you think that's a good behavior?
No.
Why?
I should get some response, otherwise I confused.
So ultimately, someone can become a BP patient or someone can get an heart attack also with this. I tried withdrawing huge amount of sum from that machine and no response was there, no cash was dispensed. So most likely my account is still safe, my balance is still safe, but no response puts me in worry. And worry is the reason for many of the heart-related diseases. Yes or no?
Yes.
So I should get a response at all costs. Yes or no? Similarly, within your team also, if your manager is asking something, you have to respond. Whether your task is completed, not completed, you're facing issue, or you did couple of extra tasks, whatever it is, your manager needs to know. Because ultimately he is also answerable to someone else. Yes or no? That's what JavaScript promises also say. It can be successful execution. It can be non-successful execution, means failed execution. At least tell me back what happened. On the top of which your structured exception handling can provide even better solution. Yes or no?
Yes.
Along with the async and await keywords, which allow you to manage the asynchronous code flow easily. Yes? Yes?
Yes.
Next is neglecting testing. So, you know, the pitfall here would be bad quality code, unexpected, undetected bugs will be there, right? So you should always focus on writing highly comprehensive unit tests, integration tests, etc., to validate your TypeScript code and make it a automated testing as part of your development workflow, which can be easily taken care of with the help of CI/CD. Yes or no? Because typically CI/CD is all about automation of some development related tasks. Yes or no? Yes or no?
Yes.
Then next one is ignoring strict mode. We already discussed this earlier. There can be inconsistencies related to the data types. If you ignore strict mode by setting option strict to false, it can actually lead to more type related issues going unnoticed. So to avoid this, always make sure that you have enabled strict option to true in the tsconfig.json file, right? Okay.
Yes.
Now some tips and tricks if I talk about to work effectively with TypeScript, what they will be based on our discussion. Always use the TypeScript with some code editor or ID, rich code editor or ID, I would say, like VS Code or WebStorm or Eclipse or Visual Studio, right? Leverage TypeScript type inference feature wherever possible. Type definitions and the add types packages should be leveraged from wherever available or wherever required. Strict mode should be always on. Custom type declarations must have the type definitions explicitly defined with .d.ts files. Otherwise, your custom type declarations will not be able to infer the data types, custom data types, especially while working with the external JavaScript code. So for that, the type definition files are important. .d.ts is the extension. Leverage the union types to combine multiple types into, in fact, to give multiple types to your variables. You can use intersection types also to combine multiple types into one. Intersection is represented by ampersand. Then use TypeScript enums to define the sets of name constant values to make your code more readable and type safe. Wisely use generics so that your code can be more reusable, more type safe. Avoid the use of any type as far as possible. Use the static typing in JavaScript also. Simply rename your JavaScript file to .ts or .tsx and add the type annotations to your JavaScript variables, which will allow you to convert JavaScript code to TypeScript code easily without the need of migrating the entire code at once. And it will be always good to go through all the options that we have available here under compiler options for TypeScript. They can be helpful, more than helpful at times. Then use comments and documentation wherever possible. Use modularity as far as possible, right? while working with React applications, try making use of the functional components. Refactoring and testing is another important aspect. Always review your code for any changes, along with any possible changes which we can plan based on the technological advancement. Means I might have created my code using React 18, but React 19 might be bringing in many good new features which might be very helpful for many of my modules in React. So keep an eye on that also, so that you can always keep up with the updates. It doesn't mean that you have to update your code immediately the moment the feature is released. You can have patience, just keep an eye. Try to evaluate the impact of that change. If it is going to be really helpful, try learning it and then try integrating that feature into your TypeScript based Java, React.js code. Understand? That's a summary of all the things that we have discussed today in the session. Yeah.
Yes.
Okay, so in the next session, we'll be focusing entirely on React.js now. And we'll be learning the React.js with a sample application being built incrementally. We'll learn a feature and we'll update our application in an incremental fashion. Clear?
Yes.
So the entire mode will be learning by doing instead of just discussion. Now, when it comes to best practices, it has to be more of a discussion all the time. Do this, don't do this, do this, don't do this. So it has to be a discussion, right?
Yes.
So that is it for today. See you again day after tomorrow, 9:30 a.m.
So
Bye-bye.
we will create a new application and we will work on that.
Yes. Yes.
Okay.
So meanwhile, those who face the issues can just find out why the issue was there, why the Create React app was not able to download all the things on its own, why we were forced to get the changes done manually, right? So that it will be making it easy for you to start up with the new application, right?
Yes.
Just try to figure out if possible. If not, then you know the solution already. Anyhow, I'll give you some extra 10 minutes to fix the same, right?
Yes.
Okay, then. Bye-bye for today. See you on Friday.
Thank you, team.
Thank you. Thanks.
Thank you.